Have you ever wondered how your body utilizes proteins? This remarkable process is known as protein metabolism, an intricate dance of synthesis, breakdown, and utilization. This is no mere waltz, but a complex ballet with each step performed with precision and purpose. To start, let's look at protein synthesis, where the cells in our body construct new proteins from amino acids. And speaking of amino acids, these are the fundamental building blocks of proteins, with 20 unique variations that each have their own distinct side chains. Then, we have anabolism and catabolism, metabolic pathways that build and break down complex molecules respectively. This includes the synthesis and degradation of proteins. We'll also explore protein turnover, a continuous process balancing synthesis and degradation to maintain protein homeostasis. From there, we'll delve into protein digestion, starting in the stomach and finishing in the small intestine. Lastly, we'll touch upon protein utilization and nitrogen balance, which help us understand how our body uses proteins and maintains balance. Now that we know what protein metabolism is, let's delve into its key concepts. First, let's discuss protein synthesis and amino acids. Protein synthesis is a fascinating process where our cells work like little factories, assembling proteins from amino acids. Picture a production line where the blueprint for each product is the DNA sequence in our cells. This sequence is transcribed into a kind of instruction manual known as messenger RNA, or mRNA for short. The mRNA then gets translated into a specific sequence of amino acids which form the protein. It's like building a complex Lego structure, one block at a time, following the instructions to the letter. Now let's turn our attention to the building blocks themselves, the amino acids. These are the raw materials in our protein production line. There are 20 standard amino acids, each with its unique side chain, giving each protein its specific structure and function. Think of these like different types of Lego blocks, each with its unique shape and color. These amino acids can be divided into two categories, essential and non-essential. Essential amino acids are the ones we need to obtain from our diet because our bodies can't make them. It's like needing to buy certain Lego pieces because we don't have the means to produce them ourselves. On the other hand, non-essential amino acids can be synthesized by our bodies. It's as if we have a Lego block maker at home, allowing us to create the pieces we need. It's important to remember that even though they are called non-essential, these amino acids are still vital for our bodies to function properly. The term non-essential simply means we don't necessarily need to consume them in our diet, as our bodies can make them if needed. To sum up, protein synthesis is the process of building proteins from amino acids, following the instructions coded in our DNA. Amino acids are the fundamental building blocks in this process, with each one playing a unique role. Essential amino acids must be obtained from our diet, while non-essential ones can be produced by our bodies. Protein synthesis and amino acids are the foundation of protein metabolism. Moving on, we have anabolism and catabolism. These two processes are the yin and yang of metabolism, working together to maintain the delicate balance of our body's protein economy. Let's start with anabolism. Picture this as the body's own construction crew. It's all about building and growth. Anabolism refers to the metabolic pathways that construct complex molecules from simpler ones. Think of it like this. If your body was a Lego set, anabolism would be the process of putting the pieces together to create a masterpiece. In the context of protein metabolism, anabolism is the process that synthesizes proteins from amino acids. This synthesis is an energy-demanding process, powered by the cellular energy currency adenosine triphosphate, or ATP for short. Now let's switch gears and talk about catabolism. Think of catabolism as the demolition crew of the body. It's the process of breaking down complex molecules into simpler ones, releasing energy in the process. In our Lego analogy, catabolism is like taking apart a Lego structure piece by piece. When it comes to proteins, catabolism is the process that breaks them down into their building blocks, the amino acids. This breakdown of proteins can serve multiple purposes. The amino acids released can be used for energy production or repurposed for other metabolic processes. So, in a nutshell, anabolism and catabolism are complementary metabolic processes. Anabolism uses energy to build complex molecules like proteins, while catabolism breaks down complex molecules, releasing energy in the process. But these processes don't work independently. They're constantly communicating and adjusting to the body's needs, ensuring that the synthesis and breakdown of proteins are in balance. So, why should we care about these processes? Well, they're fundamental to our health and well-being. From muscle growth and repair, to energy production, to the creation of enzymes and hormones, these processes are essential to keeping our bodies functioning optimally. Together, anabolism and catabolism regulate the balance of protein synthesis and breakdown. Understanding these processes gives us valuable insight into the intricate workings of our bodies and the crucial role that protein metabolism plays in our health and performance. Next up is protein turnover. This fascinating process is like the circle of life, but for proteins. It's a constant cycle of creation and destruction, synthesis and degradation, that keeps our bodies running smoothly. Picture a bustling city where buildings are continually being built and demolished, making way for new structures. That's your body, but with proteins. This process isn't random chaos though. It's carefully regulated by factors like nutrition, hormones, and physical activity. Let's say you've started lifting weights. Your body responds by ramping up protein synthesis to build and repair those hard-working muscles. On the flip side, if you're not getting enough protein in your diet, your body might break down more proteins to keep things balanced. Why is this all so important? Because protein turnover allows our bodies to adapt to changes and maintain protein homeostasis, a fancy way of saying keeping things in balance. So, in a nutshell, protein turnover ensures the body adapts to changes and maintains protein homeostasis. Now, let's talk about protein digestion. The journey of protein digestion is an intricate ballet of chemical reactions. It all starts in the stomach, where proteins find themselves in an acidic environment. Here, hydrochloric acid denatures these proteins. Denaturation is a process where the protein's structure unravels, allowing for easier access to the peptide bonds holding the amino acids together. The stomach's gastric juice also contains a potent enzyme known as pepsin. This enzyme is a protease, a type of enzyme specialized in breaking down proteins. Pepsin cleaves proteins into smaller fragments called polypeptides. From the stomach, the partially digested proteins continue their journey into the small intestine. Here, they encounter another set of proteases secreted by the pancreas. These include trypsin, chymotrypsin, and carboxypeptidase, each with their unique action. Trypsin and chymotrypsin break the polypeptides into even smaller peptides by targeting specific amino acid sequences. Carboxypeptidase, on the other hand, snips off individual amino acids from the ends of these peptides. Meanwhile, the small intestine's lining secretes additional enzymes known as peptidases. These enzymes complete the final stage of protein digestion, breaking down small peptides into individual amino acids. These amino acids, along with some small peptides, are then absorbed by the cells lining the small intestine. They cross the intestinal wall and enter the bloodstream, ready for transportation to the various cells throughout the body where they'll be put to use. This process, from the denaturation of proteins in the stomach to the absorption of amino acids and small peptides in the small intestine, is a marvel of biological engineering. It ensures that the proteins we consume in our diets are broken down into their basic building blocks, ready to be reassembled into whatever proteins our bodies need. Remember, our bodies can't use dietary proteins directly. They must first be digested into their constituent amino acids. Only then can our cells use these amino acids to synthesize the specific proteins required for their functions. Protein digestion is the first step in the body's utilization of dietary proteins. Lastly, we have protein utilization and nitrogen balance. Protein utilization refers to the various ways in which our bodies use the amino acids absorbed from the protein we consume. After digestion and absorption, these amino acids are circulated in our bloodstream and transported to where they're needed the most. These amino acids serve several critical functions. They're the building blocks for new proteins, helping our bodies to grow, repair tissues, and replace old cells. They're also crucial for the production of hormones and enzymes, which regulate nearly all biological processes, from digestion to immune response. In certain cases, if our bodies are in need of energy, these amino acids can be oxidized or burnt to produce that energy. This usually happens when we're not getting enough energy from other sources like carbohydrates and fats. Now, let's move on to nitrogen balance. Nitrogen is a key component of amino acids and therefore proteins. The balance of nitrogen in our bodies is an indicator of whether we're gaining or losing protein. It's a measure of the difference between the nitrogen we take in, primarily from dietary protein, and the nitrogen we lose, mostly in the form of urea in our urine. When we're in a state of positive nitrogen balance, our intake of nitrogen is greater than our excretion. This indicates an anabolic state, which means our bodies are building more proteins than they're breaking down. It's a state often seen in growing children, pregnant women, and people recovering from illness or injury. On the other hand, a negative nitrogen balance means we're excreting more nitrogen than we're consuming. This suggests a catabolic state, where our bodies are breaking down more proteins than they're creating. This can occur during periods of stress, illness, malnutrition, or heavy exercise without adequate protein intake. Understanding protein utilization and nitrogen balance can help us optimize our diet and health. So, what have we learned about protein metabolism? We've uncovered the intricate processes that govern how our bodies synthesize, break down, and utilize proteins. We've delved into how cells construct new proteins from amino acids through protein synthesis, and distinguished between essential and non-essential amino acids, the building blocks of proteins. We've explored the metabolic pathways of anabolism and catabolism, understanding how our bodies build complex molecules from simpler ones and, conversely, break them down to release energy. We've also touched on protein turnover, the continuous cycle of synthesis and degradation that maintains protein homeostasis in our bodies. Furthermore, we've examined protein digestion, starting in the stomach and ending in the small intestine, where amino acids are absorbed into the bloodstream. Lastly, we discussed protein utilization and nitrogen balance, revealing how proteins serve various purposes in the body, from synthesizing new proteins to producing hormones and enzymes. With this knowledge, you can make informed decisions about your protein intake and overall health. Thanks for watching.